Hello again. So we're going to do question 5 now. The question reads, a 250.0 milliliter sodium carbonate standard solution was prepared from distilled water and 21.2 grams of the solid. Describe the correct steps and equipment, including the final concentration that would be required to prepare the above solution. Cool. So what we're trying to do, I'm probably not going to go through all the correct equipment and stuff because that is just up here, and it shows you that when you want to weigh something, you're going to use scales. You're going to have some sort of something to weigh it on. So that's usually like either weighing paper or some sort of watch glass, like a glass substance. You've got your spatula to get the substance out. Once you've weighed the right amount, you'll use a funnel to make sure that you actually get all of it into the vessel. So then you'll rinse off the watch glass, as in the thing that you weighed it on, into this funnel. Then you'll rinse out all around the outside of the funnel or the inside of the funnel to make sure that you're not losing any of the substance you're trying to dissolve. Now you do this with distilled water here. Now it says swirl it to ensure it's dissolved. Just you don't want to put in heaps of water. Just put in a quarter of it filled so that you can actually swirl around properly. If you fill it up completely, you won't be able to mix it very well. Once you've done that and it's all dissolved, then you'll fill it up nice and fast until you get somewhere near the mark. And once you've done that, once you're close to the mark, you'll slow down quite a lot until you're only just putting little tiny bits of water in so that you can make sure you don't put in too much or too little water. So once you've done that, you put a little lid on it, swirl it around just to make sure it's nice and well mixed. Cool. Once you have made it up to the right solution and you do mix it, you don't need to worry about the mark anymore because, as it says here, inverting it multiple times dissolves air into the solution and gives an inaccurate reading of the true volume. So you don't have to worry about it anymore as long as you did it right the first time. So I'm not going to bother with the actually describing the steps in writing, but I will do the calculation. So the important bit here is that we've got 250 mils solution of sodium carbonate, and it was made using 21.2 grams of the solid. So we need to work out what the concentration will be. So we're not diluting anything here. We're just making up a solution. So you use this equation here, N equals C times V. So we are trying to find the concentration. So the concentration is N over V. We know what V is. V is 250 milliliters, or 0.2500 liters, just to keep the correct number of significant figures. Now N equals mass over molar mass. We are only given the grams, so that's how I know I need to use mass. So that'll be 21.2 grams over the molar mass of sodium carbonate. Now, Na2CO3, you may not know this off the top of your head, but if you look up sodium carbonate, you'll see that's the formula. So the molar mass of sodium carbonate, you can work out by having 2 times the molar mass of sodium plus the molar mass of carbon plus 3 times the molar mass of oxygen. For my purposes, I'm going to look up the molar mass of sodium carbonate, and I come up with 905.989 grams per mole. So I would recommend you try and calculate this to make sure you can do it, but that's the number just from a quick Google. Okay, so that means 21.2 grams divided by 105.989 grams per mole. The grams and grams cancel each other out. The per mole on the bottom becomes per mole on the top. I'm just going to throw this into the calculator. 21.2 divided by 105.989 gives me 0.200 moles. Now I'm doing three significant figures because 21.2 grams has three significant figures. The other one I chose however many I wanted, and it has at least four. So we're going to go with the lower number of the two, which is 0.2. Okay, so that's our number of moles. So that means we go back over here. We're going to find the concentration is our number of moles, which is 0.200 moles, divided by our volume, 0.2500 liters, which gives us 0. So dividing by 0.25, which is a quarter, is the same as timesing by 4. So that'll give us 0.800 moles per liter. Now, just as a reminder, that is the same as, 0.800 molar, which is capital M. Cool. And that's our final concentration. But the main part of this question was trying to make sure you remember how to put them together. Which, as a reminder, you've got a scale, you've got some sort of watch glass, maybe, so like a curved piece of glass. You put your stuff into there. You then take your volumetric flask and you use a funnel to make sure that you get all of it in. And you'll use let's see if I can draw this very well. That's your little distilled water thing. And there's like a little spout on the side. You want to rinse all across the inside of this funnel, as well as rinsing this watch glass down to get something like that much water. You swirl to mix, then fill up to the mark. So there'll be a mark on here, just like that. Then invert to mix. So you can invert it to mix it. That's to make sure that the concentration of your substance is evenly spread among the whole thing. And that's pretty much it. And yeah, pretty much